Okay, so topic 15.4, adding and subtracting rational expressions. We're going to go over 3 concepts. So the first concept is adding and subtracting when we have the same denominator. And then adding and subtracting when we have different denominators. And then using rational expressions in translations. So remember, a rational expression is very similar to a fraction. So there could be instances where we have the same denominator or we have different denominators. So we're going to use those same skills we learned when we were adding or subtracting fractions. We're going to do that with rational expressions. So for the first topic, we have adding and subtracting rational expressions with the same denominator. If we look right here, if we have the same denominator, then we just add or subtract the numerators, exactly like fractions. So here we have the same denominator of q. And in the first example, we're adding the numerators together. And then the second example, we're subtracting the numerators together. Okay, so exactly like fractions. And we're going to see that here because we're going to start off by using just fractions in our example. Okay. So in number 1, we have 1 over 12 plus 7 over 12. So we have the same denominator here. So we're going to do what to the numerators? Add them. So we have 1 plus 7 over 12, which gives us 8 over 12. Can we reduce that? By what number, top and bottom? Good. So we can divide both top and bottom by 4, and we get 2/3. That's our answer. You could divide top and bottom by 2 and you would get 4 over 6, but 4 over 6 can still be reduced to 2 over 3. So you just keep reducing until you can't anymore. Okay. So we're going to take that concept of just regular fractions and we're going to apply that concept to number 2. So on number 2, we're checking if they have the same denominator. Do they? Yes or no? Yes, they both have 5p, meaning that 5p is going to stay the same, and we're just adding our numerators. So 2 plus 7. So 2 plus 7 is 9, and we have 5p on the bottom. Can we reduce that 9 and the 5? Nope, so this is our answer, 9 over 5p. Again, this first concept, exactly like regular fractions, if we have the same denominator, we are just adding the numerators. So on number 3, we have 2 over 3d plus 5 plus 7d over 3d plus 5. Do they have the same denominator? Yes, so that's going to stay the same. So the bottom is 3d plus 5. And then we need to add our numerators. So we have 2 plus 7d. Can we simplify 2 plus 7d and make it 9d? No, why not? Good, they're not common terms because the 2 is just a constant number and the 7d has a variable. So since we can't combine those or simplify those further, this is our answer. So again, we are just practicing when they have a common denominator. Okay, now let's look at number 4. So number 4, do they have common denominators? Yes, that means our denominator is going to stay what? X minus 3. And then now it's telling us to subtract our numerators. So if I'm going to subtract them, I need to make sure when I'm rewriting my numerators that that second numerator is in parentheses. So I have x squared minus negative 5x plus 24. And the reason I'm doing that is because that minus is going to change that part of the numerator. So what am I going to do to that minus sign?
Switch it.
Good, it's going to switch all the signs. So I distribute that in, and it's going to switch all the signs. So I now have x squared plus 5x minus 24 all over x minus 3. Would this be our answer, or could we simplify this further?
Simplify.
Simplify. What would we try to simplify?
Trinomial up top. Factor it.
Good. We need to try to factor this trinomial at the top because it looks like that standard form of ax squared plus bx minus c. So we're going to factor that using which method? AC method. So we have a times c, which is what? Negative 24. And our b value is 5. So what would be two factors that multiply to negative 24 but add to 5? 8 and negative 3. Perfect. Because 8 times negative 3 gives us negative 24, but 8 plus negative 3 gives us 5. So we're using these factors. We're going to expand that trinomial. And so we get x squared plus 8x minus 3x minus 24. Now how are we factoring this? Factor by grouping. What's the GCF we can take out of the first pair? X, so we're left with x plus 8. What about the second pair? Negative 3, so we're left with x plus 8 because we want those parentheses to match. So that means we have our factors x minus 3, x plus 8. Okay. So when I go to rewrite my trinomial, I'm going to write those factors instead. So I have x minus 3, x plus 8, all over x minus 3. Is this the answer, or can we simplify further?
Simplify.
Good, we can continue to simplify because what would cancel? X minus 3. So that means we're left with our answer of x plus 8. Okay, so we combined our numerators. We noticed that when we did that, we got a quadratic equation that could be factored. We go over to the side and factor it using the AC method and then factor by grouping. And then we put it back into the equation, see if anything can cancel. And then in this case it did, and we were left with x plus 8. So not every time will you end up with an answer that is a fraction, because sometimes the things will cancel out. Any questions on 4? Majority of your problems are going to look like this, where we're going to have to use the skills of factoring to factor something and then cancel. Okay. Let's look at the next concept here. So concept 2 is adding and subtracting when we have different denominators. So if we just think of a regular fraction, when we have different denominators, what do we have to do? We have to get a common denominator, right? So if you had like 1/2 and 2/4 or something like that, you had to get the common denominator of 4. So we're going to be doing the same thing here, getting that common denominator before we add or subtract our numerators. That's pretty much what this whole thing is saying here. Got to get a common denominator. In these cases, since we have variables in our denominator, a lot of the time we're going to just end up multiplying those denominators together to get our common denominator. So let's see. Can't figure out least common denominator, then multiply denominators together. Okay, this is the important information from that red box. So if we have different denominators, we need to find a common denominator. If we can't figure out that common denominator, we multiply the denominators together, and that is our common denominator. Okay. Let's go ahead and look at number 5. Okay. Number 5, we have our two rational expressions, 4 over 7k minus 3 over k squared. Do they have a common denominator? No. What is missing from this first fraction in order for them to have similar denominators? Good, it's missing that squared, right? So that squared tells us that instead of 1k, there's how many k's? 2. So that means this part of the fraction is just missing a k. So I'm going to multiply top and bottom by k. So now I have k squared, k squared. However, there's a 7 in that first one and not in our second one. So that means our second one is just missing a what? 7. A 7. So we're going to multiply top and bottom by 7. So when we do that, our denominator is going to be 7k squared. Okay, so now they're the same, 7k squared. On the first fraction, we have 4 times k, which is 4k. And then we have 3 times 7, which is 21. Okay, so I just rewrote my expressions with a common denominator. Now that they have a common denominator, what am I going to do to the numerators? What's the sign right here? I'm going to subtract them. So I have 4k minus 21 over 7k squared. Now I'm looking at that numerator and I'm seeing, can I factor anything out from that numerator? Yes or no? No, I can't. There's nothing I can factor out from 4k and 21. So that means this is my answer. This is the most simplified I can get it, is that 4k minus 21 over 7k squared. Eventually, we'll get to the point where we'll be able to factor something out of the numerator and it potentially cancel with the denominator, just like on number 4. Number 6 has 2 different denominators, but they're just numbers this time. So what would be the common denominator between 3 and 2? 6. Meaning we would have to multiply the first fraction by 2 in order to get our 6, and the second fraction by 3. Okay. So when we do that, we're going to have 2 denominators that are the same, that both have 6 on the bottom. Now we just got to write our numerators. When I'm multiplying the first numerator by 2, what am I going to be doing with that 2? Distribute. I need to distribute that 2 to every term. Same with the 3. I need to distribute that 3 to every term. So that means in the first fraction, I have 2 times 2q, which is 4q, and 2 times negative 4, which is negative 8. So that would be my first new numerator. In the second one, what would I get after I distribute the 3? Good, 3q plus 3. Okay, so these are my new expressions, now with a common denominator. What am I doing with the 2 numerators now? Subtracting. So I have 4q minus 8 minus, and I need to put that second numerator in parentheses because of that minus. So 3q plus 3 all over 6. What happens with the 3q plus 3 since that minus is on the outside?
Signs will change.
Good, the signs will change. So instead of a positive 3q and a positive 3, they're going to be negative now. So I have 4q minus 8 minus 3q minus 3 all over 6. Is this simplified? No, what do I need to do next? Combine like terms. And what are my like terms for q? What am I going to end up with? Just q. And what about the numbers, negative 8 and negative 3? Negative 11 over 6. Okay, is this simplified? Yes, because I can't simplify anything in the numerator any further, anything in the denominator, so this is my answer. So again, I had a different denominator, so in order to get a common denominator, I'm going to have to multiply each fraction by what it's missing. Let's look at number 7. So in number 7, we have two denominators. One is that x minus 5, and the other is x squared minus 25. Right away, your eyes should go to which denominator, the first or the second? The second. Because what does that second one tell you?
Perfect square.
Perfect square. And how do we factor a perfect square? Take the square root of both terms. So I'm going to have a x minus 5 and an x plus 5. So now knowing that this factors to x minus 5 and x plus 5, what is that first fraction missing? X plus 5. So what are we going to multiply that fraction by? X plus 5, top and bottom. X plus 5, x plus 5. Okay. When we do that, we are going to have the denominators of x minus 5, x plus 5. You do not need to multiply it back together because it could end up where when we combine our numerators, there's something that can cancel. So we would leave it as is. So I'm writing my new fractions now that they have common denominators. So the second fraction staying the same because we don't need to multiply it by anything. But that first fraction is going to have x plus 5 times 1. So what's going to be at the top here? X plus 5. Okay. Now that we have a common denominator, we're going to add our numerators. So I have x plus 5 minus 10 over our common denominators, x minus 5, x plus 5. How is that numerator going to simplify?
Cancel out minus 5.
X minus 5. Okay, remember, we got to simplify this part first because we have our like terms. So 5 minus 10 is negative 5. So we have x minus 5 over our denominator, x minus 5, x plus 5. Now what can we do? Cancel out. So if I cancel out that x minus 5, there's nothing left in that numerator. So what would I write? 1. So my answer is 1 over x plus 5. Okay. Remember, we can't cancel this x plus 5 and x plus 5 right away because of that minus 10. We have to be multiplying terms together in order to cancel. There can't be an addition or subtraction between them. So on these type of problems, if you see a perfect square as the denominator, factor that first because more likely than not, it's going to match up with something in your other denominator. Any questions so far? Okay, let's look at number 8. What's different about number 8 versus everything else? We no longer just have 2 fractions, we have how many? 3, meaning we have to get a common denominator between all 3 fractions. So right away, your eyes should be looking at which fraction, 1, 2, or 3? 3. Why should it look at 3 first?
It's a factor.
Good, because this is a trinomial that can be factored. And how would we factor this? The AC method. So A times C is going to be what? -6. And what's our B value? So we need 2 numbers that multiply to -6 but add to 5. 6 and -1. So 6 times -1. If we multiply that, we get -6. And if we add 6 plus -1, we get a +5. So we're using the factors 6 and -1. So when I expand my problem, p squared plus 6p minus p minus 6, I'm now going to be factor by grouping. So when I do factor by grouping, what's the GCF I can take out of the first parenthesis? A p, and I'm left with p plus 6. What about from the second parenthesis, because we want it to match? So if we take out a 1, nothing's going to change. A -1, and that takes out those negatives, and we're left with p plus 6. So that means our 2 factors are p minus 1 and p plus 6. Where else do we see those factors? Good, the denominator is here. So that's telling us that the first fraction is missing what? The p plus 6, and the second fraction is missing p minus 1. Okay, so I'm going to go ahead now and I'm going to multiply this first fraction by p plus 6. Second fraction by p minus 1, because that's what it's missing. And what about that third fraction? Do we need to do anything to it? No, because it already has p minus 1 and p plus 6, because we just found that. So now all our denominators match. We have a p minus 1 and p plus 6 on every single one. And then on that last one, that 14 stays there because there's nothing that's changing. So for that first fraction, on the numerator, we have p plus 6 times p plus 2. And am I going to FOIL these or leave them as factors? So we're going to leave them as factors because, remember, we can end up at the end canceling something out if it's already factored. So I'm just going to write p plus 6 times p plus 2. I don't need to FOIL that back out. What am I going to have on that second fraction?
2p minus 2.
Correct. 2p minus 2. Because that 2 is being distributed into that p minus 1. Okay. Now, I have these new fractions where everything has a common denominator. So now I'm going to subtract every one. So I have p plus 6, p plus 2, minus, I need to put that second one in parentheses, 2p minus 2 minus 14. All over my denominator. Okay. Is there anything I can combine on the top as my like terms? Good, I can combine, first distribute that negative in, that's going to change my signs, and then I'll be able to combine that 2 and that negative 14. So I'm leaving that p plus 6, p plus 2. This becomes minus 2p plus 2 minus 14. I can combine these to be negative 12. Okay. So I have p plus 6, p plus 2, minus 2p minus 12. Okay, I'm still just focusing on that numerator right now, simplifying that. Can I take a GCF out of that negative 2p minus 12? Yes, what GCF can I take out of that? I could take out a 2 or I could take out a negative 2. When I do that, I have p plus 6, p plus 2, take out a negative 2, and I'm left with p plus 6. Okay. Now looking at the entire numerator, what does the first part have in common with the second part? P plus 6, meaning we could factor out a p plus 6. So we would have p plus 6, and then from the first part, we would be left with p plus 2, and in the second part, we would be left with a negative 2. Okay. What would cancel inside of those brackets? What would cancel inside of the brackets? We have a 2 and a minus 2. Would those cancel? So now I'm left with p plus 6 times p. Okay, that is my simplified numerator. What was my denominator again? P minus 1 times p plus 6. Is this my answer, or can I simplify further? Simplify by canceling p plus 6. So I'm left with p over p minus 1. Is this as simplified as it can get? Yes or no? If you say no, why? Okay, remember we can't cancel out the p's because the p on the denominator has a what next to it? A minus 1. So that means this is our answer. Yes.
Run by me one more time the bracket part.
Yes. So the only reason I put the brackets there is because I already had a bunch of parentheses. And I didn't want to add another set of parentheses, so I just changed it to brackets. So how we got that is we looked at this entire thing here, and we are looking for what they have in common, the GCF, what we can factor out. And we said that they both have a p plus 6 here. So I moved that p plus 6 to the outside, and everything that was left, I put inside those brackets. So I had a p plus 2 left and a negative 2.
So you're kind of, in this sense, kind of doing like a factor by grouping in the sense that you're looking at the first half and the second half separately, not as one like addition.
Correct,
Okay.
correct.
Gotcha.
This is almost like the part in factor by grouping where you're like, okay, we do have the same parenthesis. We have the p plus 6, p plus 6. So it is that same concept. Okay, and then remember that this whole section here, this was me reducing the numerator instead of me writing the denominator again under it 4 more times. I just had to remember at the end to bring my denominator back. Okay. Any questions over 8? That is as complicated as a problem could get. Okay, where we have to continue seeing if anything can factor out and reduce. Okay, now let's look at number 9. So number 9 is pulling from a concept that we learned on Monday. Because remember on Monday we said that if we had something like, in this example, d minus 7, that is not the same as saying 7 minus d. So these are 2 different denominators. What did we learn on Monday that we could do to one of these denominators to make them match? Multiply by -1. So it doesn't matter which one we're multiplying by -1. So I'm just going to choose the first one. And when I multiply that by -1, I get -d plus 7. Okay. Now that I have a plus that's separating these 2 terms, I'm able to flip-flop them because it doesn't matter in addition if the number comes first or second. So I'm able to switch these around, and this becomes 7 minus d, which now matches my other denominator. So all I did was multiply that first fraction by -1. So that means I have -1 over 7 minus d plus 5 over 7 minus d. Okay. Now that I have the same denominator, what can I do to the numerators? Add them. So what's -1 plus 5? 4. So I have 4 over 7 minus d. Can the numerator or the denominator simplify further? Nope. So this is my answer. The only way this would become confusing is if you see this on the exam and you think they are the same. Okay, because then if you think they're the same, you're going to get 6 over 7 minus d, which is wrong. Okay, these are completely different, and the way that we make them the same is multiplying one of them by -1. Any questions on concept 2? So this involves a lot of factoring, okay? Okay, concept 3, which is the last concept for this section, is using rational expressions in translations. So what this means is we have word problems that we are going to set up our rational expressions and solve. So for number 10, it says, write this phrase as a mathematical expression. Okay. The difference of the reciprocal of n in the quotient of n is 3. So here's 2 words we need to know, reciprocal and quotient. So what does reciprocal mean?
Subtraction.
We flip it. So this is, reciprocal means flip. What does quotient mean?
Divide.
And the division of n. Okay, quotient does come from divide, but what part of the divide? So how would we write that in as a quotient? Good, because look right here, it says the quotient of n and 3. So we wouldn't just have n in there, it would be n.
Plus 3?
Quotient means divide. So
I mean the...
it would just be n over 3. N divided by 3. Because it says n and 3. And quotient means divide. So in this one, we have the reciprocal of n, so 1 over n. And then it says the difference of the two, so what does that mean? Minus, so 1 over n minus, and then we said n over 3. Okay, so we have the expression 1 over n minus n over 3. Now let's simplify this by getting a common denominator. And what would the common denominator be for n and 3? 3n, right? Because the first one is missing a 3. And the second one is missing an n. So when we do that and we multiply together, we now have the common denominator of 3n. Okay. On the first numerator, we have 3 times 1, which is 3. And then in the second one, we have n times n, which is what? N squared. So if we were to combine these, this is 3 minus n squared over 3n. Okay. Remember, when we have something that's squared, we have to have that square component come first. So technically, I could write this by swapping those terms. I have negative n squared plus 3 over 3n. And then I don't want the negative in the front, so what could I do to everything in the numerator to change those signs?
Swap it around.
Good, I could multiply everything by a negative 1, and I get n squared minus 3. But since I multiplied the top by a negative 1, I have to also multiply that bottom by a negative 1, so I get negative 3n. From here, I'm now looking at that numerator. I have n squared minus 3. So this looks like it could be a what? It looks like it could be a perfect square, but is 3 a perfect square?
No.
No, so that means this is our answer.
Now on something like this, is it gonna matter if we have like the negative in the denominator as opposed to just in front of the whole fraction?
No, that's the same thing.
Okay. So
Even if, so on an exam, if you stopped here, this is still correct. So if you stopped here, I would give you the full points. This was me checking to see, okay, what if I put it in the correct format, would I be able to factor? So I would still do that in your head, okay? If I put it in the format, would I be able to factor? If you see that it's not factorable, then this is your answer, and I wouldn't expect to see these other two steps. Okay. Any questions on 10? Okay, last one, number 11. Says write this phrase as a mathematical expression. So we're just looking at this part. The sum of 1 and the quotient of 2 in A. So if we're looking at our two fractions here,
1 plus 2 over a.
1 plus 2 over a. Correct, because sum gives us the plus, but since we want everything as a fraction, I wouldn't just write 1, I would write 1 over 1, because that's the same thing. So 1 over 1 plus the quotient, which we know is divide, 2 and a. So 2 on top, a on bottom. So the reason I put 1 over 1 is because I'm still trying to get a common denominator. So I had to have everything in terms of a fraction. Okay? So this is what the expression would look like. We need to get a common denominator, and what would that common denominator be? A. Or you could say 1a, but do we need to write the 1 there? No, it would just be a, which means which fraction is missing the a? First one. So I'm going to multiply top and bottom by a. Do I need to do anything to the second fraction?
You do? No.
No, because it already has an a, right? Okay. So now we have a plus, and then a on the bottom here. Looking at the first numerator, we have a times 1, which is a, and then the 2 doesn't change in the second one. So if I was to add these numerators together, I would get what?
A plus 2
Over a. Is this as simplified as it can get? Yes. Why? Good. We can't cancel the a's because it has a plus 2 up here. Okay. Anything that has a plus or a minus attached to it, we can't cancel. If this was like a times 2, then we could cancel the a's because they're being multiplied. But since this is not the case, this would be our answer.